Have you ever stood in front of a monument that's seen centuries of history just roll by? Well, what if I told you its greatest protector today isn't a team with chisels and mortar, but a beam of light and a line of code? It's pretty amazing to think about. We're going to dive into this incredible world where ancient heritage meets futuristic tech and see how things like lasers and AI are becoming the last best hope for our most treasured historical sites.
So this is really the big question, right? How do you protect a structure built for a world of horse-drawn carts from all the pressures of our world? We're talking about the constant deep rumbling from subways underground, the chemical bite of pollution, and the totally unpredictable weather from a changing climate. It's a huge challenge. Our past is literally facing a future it was never, ever built for.
So to really get how we're solving this, we're going to walk through it step by step. First, we'll look at why our history is under so much pressure. Then we'll get into the digital blueprint. That's the high-tech diagnosis. We'll trace the path from lasers to logic, see how it creates what's called a living digital asset, and then finally, we'll wrap our heads around what it really means to engineer continuity for the future.
Okay, first things first, we need to diagnose the patient. And to do that, you have to stop thinking of these incredible buildings as just static objects made of stone. A much better way to see them as living patients who are constantly fighting off different ailments and need very, very specific care.
I mean, just think about it. A medieval cathedral wasn't designed to handle the nonstop vibrations from a subway line running nearby, or the acidic cocktail of modern pollution. On top of that, it's dealing with new pressures like massive crowds of tourists, heavy construction next door, and of course, extreme weather. These sites are being pushed to their absolute breaking point by things their builders couldn't even have imagined.
And here is the absolute heart of the problem. If you're an engineer working on a modern skyscraper, you can pull up the original digital blueprints, all the material specs, the CAD files, the whole shebang. But for these ancient structures, there's nothing. They are, for all intents and purposes, patients showing up in the emergency room with zero medical history. No charts, no records, and that makes figuring out what's wrong, let alone how to treat it, unbelievably difficult.
So if these buildings are patients without any medical records, technology is about to write them from scratch. This is the moment we shift from making educated guesses to performing a data-driven, high-tech diagnosis. We are literally about to create what you could call a digital blueprint. And the key concept here is something called a digital twin. Now, this isn't just some pretty 3D model you can spin around on your computer. A digital twin is more like a complete digital body scan of the building. It's a living model, packed with data that contains every last bit of information about the building's shape, its materials, and its current health.
So here's the bottom line. The whole point is to take something that's purely physical, centuries-old stone, timber, and mortar, and transform it into an intelligent digital version of itself. We're essentially giving these ancient structures a digital brain that can tell us exactly what's wrong and how we can fix it.
All right, so how does this actually happen? How do we go from a huge physical building to a smart digital model? Well, it's this fascinating three-step process that basically takes us from capturing physical reality to creating digital logic we can actually use.
Okay, so it all starts with capture. Teams use these incredibly precise laser scanners and something called photogrammetry, which is basically stitching together thousands of photos to create what's called a point cloud. It's like a perfect digital map of every single curve and crack. Step 2 is convert. All that raw data gets transformed into an intelligent building information model, or BIM. This is where the data gets smart. The model now knows that a pillar isn't just a shape, it's a load-bearing structure made of a specific type of stone. And finally, analyze. With this intelligent model, engineers can run earthquake simulations, test out different repair strategies, and plan restorations with surgical precision, all without ever touching the real building.
So once this digital twin is made, it's not a file you just save and forget about. Nope, it becomes a living, breathing digital asset. And the impact this has on preservation? Well, it completely rewrites the rules of what's even possible.
The new capabilities are just incredible. We can now model every single irregular, hand-carved surface with millimeter accuracy. We can create condition maps, think of them like a heat scan for decay, that show us exactly which stones are failing. We can digitally test new support structures to see if they'll work before installing them. And we can even analyze the environmental impact of our restoration plans, making conservation itself more sustainable. It's a game changer.
And this comparison just lays it all out perfectly. It shows the massive shift in thinking. You see, in the past, preservation was static. It was reactive. We'd document history and then basically wait for something to break before we fixed it.
But today, with a digital twin, we have dynamic monitoring. We can actually predict what needs maintenance before it becomes a catastrophe. We can engineer solutions with data. We are actively managing the building's performance over time. We're playing offense now, not defense.
Okay, so let's zoom out for the final piece of this puzzle. Why does all this tech really matter in the grand scheme of things? Well, because this is about so much more than just fixing old buildings. It's about engineering their continuity and locking in their future.
At the end of the day, the goal here is pretty profound. We are no longer just the passive guardians of the past. By creating these living digital assets, we are actively digitizing a legacy. We're handing the next generation not just a beautiful monument, but also the complete digital user's manual they'll need to understand it, care for it, and make sure it's still standing for their kids too.
And that leaves us with this really powerful idea. The job of preservation has completely changed. It's evolved from just an act of protection into an act of engineering. It's about using data, precision, and some incredible foresight to make sure our past has a vibrant and lasting future. And it really makes you wonder, doesn't it? What other parts of our world are just waiting for their own digital twin?